Good morning. It's June 17th, and this is your daily brief in science. Here's everything you need to know. A new study reframes how we think about protecting coral reefs, showing that only about 28% of reefs currently fall within protected or conserved areas. Conducted by the Wildlife Conservation Society and Macquarie University, the research challenges some IPCC projections by offering a more hopeful view for coral reefs, while stressing that protection remains essential as protection coverage is still a minority. The study identifies roughly 166,000 square kilometers of climate-resilient reef across 71 countries and 100 territories, about 3 times prior estimates, and notes these resilient reefs are found in cooler microclimates, have evolved heat tolerance, or recover more quickly from bleaching. Coral bleaching happens when elevated temperatures cause corals to expel symbiotic algae, zooxanthellae, and recovery varies with the reef's resilience. With an upcoming El Niño event, the findings highlight urgency to act now to safeguard reefs under the 30 by 30 target, given the current protection gap. The research aligns coastal communities with socioeconomic stakes, as reefs support hundreds of millions of livelihoods, coastal protection, culture, and jobs, making resilience a priority for both biodiversity and people. Kenya's Wasini-Makwiro region showcases proactive local stewardship, including community-led data collection, anti-poaching patrols, and restoration efforts like planting seaweeds and mangroves linked to reef health and tourism. Around the world, conservation programs are already applying these data, from Hawaii's climate resilience guided reef management to Indonesia's zoning based on thermal tolerance and Bahamas' reef action plans tied to financing. The study, peer-reviewed and funded by Bloomberg Philanthropies, arrives as governments prepare for a looming super El Niño that could intensify stress on coral ecosystems. 3 brain cell types enter a senescent state during development, including vascular endothelial cells, brain-resident macrophages, and choroid plexus epithelial cells, each contributing to the formation and function of the barriers between blood, brain, and cerebrospinal fluid. Developmental senescence appears context-dependent. It can be transient and beneficial during development, but may be harmful if persistent later in aging. The study offers a nuanced view of cellular senescence, noting beneficial roles in development while considering potential relevance to brain diseases as researchers explore links to pathology. Funded by the NIH and UC San Diego departments, with authors such as Ashley Watson and Meherena among the researchers involved. Persistent senescence in adult choroid plexus cells raises questions about regulation and possible connections to age-related changes in brain fluid dynamics and infection susceptibility. A UC Davis-led study finds loneliness is a stronger predictor of cognitive decline and mortality in adults over 50 than objective social isolation. Across 175,000 participants in 18 countries, a 10% rise in loneliness reports links to about an 8% to 9% higher risk of severe cognitive impairment and a slower recovery from mild impairment. Loneliness and social isolation are distinct. Loneliness is a perception, even in crowded settings, while isolation is the physical state of being alone. The research, published June 15th in the Journal of Personality and Social Psychology, uses coordinated multi-study analysis to separate the effects of loneliness from isolation and to inform public health strategies. NIH-funded, with collaborators from USC, Northwestern, UCL, and other institutions, the study notes that loneliness remains significant even after accounting for social isolation. The findings align with Loneliness Awareness Week's message to destigmatize loneliness and promote conversations and opportunities to build connections. Context notes highlight that loneliness affects adults internationally, with 22% of English adults reporting loneliness at least some of the time in 2024, and about 1 in 3 U.S. adults experiencing loneliness. Younger adults in England report loneliness more than those aged 65 to 74, suggesting it is not only an issue for older people. The article calls for broader screening in hospitals and care networks and for building social infrastructures that foster genuine belonging and emotional alignment. Beyond care costs, the researchers emphasize the need for further work to understand why loneliness may be more harmful than isolation and how identity intersects with loneliness experiences. A A new upgrade to NASA's Cold Atom Lab on the International Space Station is expanding the reach of quantum science in microgravity. The upgrade aims to advance experiments that study ultra-cold matter and push forward space-based quantum technologies. Researchers use laser cooling to trap rubidium or potassium gases in a vacuum, extending observation times thanks to the microgravity environment. Quantum science looks at matter at the smallest scales, where atoms behave like waves and can form a Bose-Einstein condensate under extreme cooling. Project scientists say the upgrade moves space-based quantum tools toward reliability and leadership in the field. Microgravity allows longer observation periods and larger quantum waves, improving precision in time, gravity, and motion measurements, and enabling tests of quantum phenomena in space. 5 international teams are involved in the experiments, and the upgrade matures these instruments for future Earth science and space missions. Caltech runs the Cold Atom Lab, with JPL handling design, construction, and operation under NASA's Biological and Physical Sciences Division as part of the broader science mission. NASA notes that the project demonstrates leadership in space-based quantum technologies and matures instruments like matter-wave interferometers for fundamental physics missions, navigation, timing, and gravity sensing beyond Earth. The lab cools atoms to ultra-cold temperatures, below -459 degrees Fahrenheit, -237 degrees Celsius, using laser cooling and magnetic traps to study large quantum waves, including Bose-Einstein condensates. This is the 4th upgrade since 2018 and includes a redesigned magnetic trap and new metal strip sources, broadening the lab's ability to generate and shape quantum gas clouds. A new open dataset called IBD-Verse maps gene activity across more than 50 gut cell types in Crohn's disease, based on a large-scale single-cell RNA sequencing study that analyzed biopsies from patients with terminal ileitis and healthy volunteers. The resource contains about 1.18 million gut cells and is intended to support future Crohn's and broader inflammatory bowel disease research. The study identifies cell-type-specific gene expression changes and molecular inflammation signatures, using scRNA-seq to detail how different cells react during inflammation. Functional validation includes interferon gamma-induced organoid experiments, showing coordinated upregulation of IFN signaling and MHCI pathways across epithelial cell types, indicating epithelial intrinsic antigen presentation during inflammation. However, the researchers note limitations, including less than 50% replication of differentially expressed genes between discovery and replication cohorts, and variability across cell types, underscoring the need for larger studies. A major finding points to ITGA-4 high macrophages driving inflammation via the JAK-STAT pathway, with elevated cytokines such as IL-6, IL-12, and IL-23, suggesting JAK inhibitors as potential therapy. ITGA-4 positive and CD163 positive macrophages are enriched in inflamed tissue, showing upregulated cytokine signaling and IL-6 IFN pathways, with JAK2/STAT1 signaling linked to their activity and to immunoproteasome MHCI communication. The work identifies a macrophage population with high ITGA-4 expression as a key inflammation driver through JAK-STAT signaling, highlighting therapeutic targets including JAK inhibitors used in IBD. Differential expression reveals thousands of DEGs in inflamed tissue, particularly in epithelial cells and T cells, with replication across cohorts varying by cell type. The study emphasizes open science and replication, reporting that only a subset of expression changes replicated across cohorts. Yet, replicated signals consistently point to meaningful epithelial immune interactions in the gut. Genetic data integrate Crohn's heritability with specific cell types. Node 2 is enriched in certain monocytes macrophages, but not broadly dysregulated, and NOD2+ cells are major sources of oncostatin M, a potential biomarker or target. A lasting molecular scar is identified in gut epithelial progenitor cells where interferon-driven MHC class I upregulation persists after inflammation resolves and may affect future responses. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.